can actually factor the numerator and the denominator. So in factored form, if there's a common factor in both the numerator and the denominator, the graph is going to have a hole at that point. So if there's a number that's exactly the same, so right here, there's a minus p in the numerator and a minus p in the denominator, that means that's going to cancel out, and we're going to have a hole in the graph. And I'll show you what a hole in the graph looks like once we graph it. Once we cancel this hole out, whatever is left over, this is called the reduced form. You do exactly the same thing we did to get everything else. The x-intercept is the numerator. The vertical asymptote is the denominator. The y-intercept is the constant. What's the other thing I missed? The horizontal asymptote are the numbers in front of x, the coefficients. Once we cancel the whole out, it's exactly the same that we just did. So I just want to concentrate on the whole part. And then, with one problem, I'll review how to get all this other stuff. But again, this is exactly the same. So if you want, go back and look at your front page. Y is 0. The factors of the numerator, undefined. The factors of the denominator. That's exactly the same as before. Alright, so I'm not going to spend time right now. You can click through it if you want it. I want to make sure we get enough practice problems in. Alright, so looking at this practice problem. This is the part I was talking about for pre-cal. I should be able to say factor the numerator and denominator. You should be able to do it. Okay, maybe not today, but I'll review it with you today. Maybe a little bit more on Wednesday. But that's all that's going to happen in pre-cal, is they're going to say factor, because that's not the answer anymore. The factor form is not the answer. That's our intermediate step. We need factor form to get some of these answers. Alright, so let's review how to factor this. Because there's 3 of them, I'm going to use the x factor for the numerator. Since there's not a number in front of x squared, then it's just a basic factoring, where I put this number on the bottom and this number on the top. And eventually in pre-cal, you're not even going to show the x. You're just going to go over there and fill in the parentheses. So what are the factors of 12 that give me 7? 1 and 12, 2 and 6, 3 and 4. Which combination is going to add together to give me 7? The 3 and the 4. So factored form would be x plus 3 and x plus 4. And you got to do the same thing for the bottom. So if you look at the denominator, we're going to put the 8 on the bottom and the 6 on the top. So the factors of 8 are 1 and 8 and 2 and 4. So which would add together to give me the 6? The 2 and the 4. So in the denominator, I'm going to factor it as x plus 2, x plus 4. Okay. So again, for these, you need factor form. That means quadratics. That's how we simplify them. Is in factor form. That's how we're going to have to solve them as well. Is in factor form. For the whole, I want the common factor. So what is common? What parentheses is common for the top and for the bottom? So if we look at our factor form, what thing is exactly the same? The x plus 4, thank you. So the x plus 4, that's going to cancel out. And, really, yes, you set it equal to 0. But when you solve it, minus 4x is going to be equal to negative 4. Here's the thing though. A hole is not a line. A hole is a point. So right here, the negative 4 is the x value. We have to find the y, and it's not 0. So before I actually show you how to find the y, let me come over here and show you what the heck this thing looks like. How does a graph have a hole in it? So we have 7x squared. Where's my keyboard? Way over there. 7x squared, or x squared plus 7, sorry. Plus 7. And then 12. And then x squared plus 6x plus 8. Okay, so we're still dealing with the hyperbola shape, the whole double L. It gives you some of the answers, like the Desmos will give you the x-intercept. It'll give you the y-intercept. It won't give you the asymptotes, like explicitly. You can visually see what the asymptotes are, but it won't just say it. You kind of have to figure it out. But the hole in the graph, you cannot see the hole in the graph. It is so tiny. I mean, it's a speck. It's a pixel. So you can't really see it in the graph. But if you trace it, you'll be able to tell. Where was it at? Where's the number? So if you trace it to negative 4, so if you kind of move your cursor, so you get to like negative 4. Let's see if I can. It has to be like exactly on it. You'll see that it says undefined there, but I can't keep it still enough to have it stay there. It's a hole in the graph. It's like an open circle in the middle of your graph. So it has a specific coordinate, or it's 5, that you have to figure out what it is. And you can kind of figure it out because your numbers get closer and closer to it. But the way we figure it out algebraically, you take, going over it, you take your reduced form. So right now, I'm going to cancel out my hole. This is my reduced form. What can I write my reduced form? Right. Y equals x plus 3 over x plus 2. You take your x coordinate and you plug it in for the x's, and then you just divide the numbers to figure out your y. So instead of both of these x's being there, we're going to plug in negative 4, because that's what we solved for. Negative 4 was the x. We plug in the negative 4, and we find the y. So negative 4 plus 3 is negative 1. Negative 4 plus 2 is negative 2. So negative 1 divided by negative 2, negative and negative makes 1/2. So 1/2 would be the y coordinate. So you take the reduced form, take out the hole, take the reduced form, plug in the number that you got for the x, plug it in for the 2 x's, simplify the numerator, simplify the denominator, and solve. Everything else is the same. So your vertical asymptote, you're going to use your reduced form and look at the denominator. So I'm just going to kind of do these quickly, but because you've already done these. So x would be negative 2, because if I set it equal to 0 and solve, that's what I would get. The x-intercept is the numerator equal to 0. Numerator equal to 0, subtract 3, I would get negative 3 as the x-intercept. Horizontal asymptote, look at the numbers in front of x. 1 over 1 is just 1. And y-intercept, you look at your constants, 3 over 2 is just 3 over 2. But you would write it as the point. Alright, so that part's the same. The vertical, the asymptotes, and the intercepts are exactly the same, but now you just use the reduced form instead of the original form. The whole is the new part. So I'm going to do a couple more examples where we're just finding the whole, and then you'll be able to go finish those ones on the homework. Alright, so again, you can kind of click through it. It does the same thing. This one kind of tells you step by step how to find the whole if you want to go back and look at that. But for number 5, we're going to find the whole, not all that other stuff. For number 6, we'll find the whole, not other stuff, and then you'll go do that for the homework one. Alright, so looking at number 5. Let me give you, okay, so x plus 1, x minus 3 in the numerator, x plus 1, x minus 6 in the denominator. For the whole, we're looking for the common factor between the two. So what factor do they both have in common in the numerator and the denominator? The common factor is x plus 1. They have to be the same sign. If one is an x plus 1 and that one is an x minus 1, that's not common. Okay, they have to be exactly the same. And you set that common factor equal to 0 and solve for x to get your x number. So negative 1 is your x number, which really is just the opposite. I mean, you don't have to actually show work for solving first for that one. But the y, you probably have to show a little bit of work for yourself. For the y, we cancel out the whole, and we take what's left and plug in negative 1 for the x's. So we have x minus 3 and x minus 6 left over. So for the x's, we're going to plug a negative 1 in here and a negative 1 in there. So negative 1 minus 1 is, negative 1 minus 3 is negative 4. Negative 1 minus 6 is negative 7. And then I just divide those two together. Negative 4 divided by negative 7. Negative and a negative makes positive 4 over 7. Usually the whole is going to be a fraction. A few times you might get a whole number, but usually it's a fraction in there. Just leave it as a reduced fraction. No decimal, and especially not for this one. No mixed numbers, just improper fraction. For everything else, you would do the exact same thing with our simplified form over there. So again, ignoring the whole, you just take this right here. Numerator gives you your x-intercepts. Denominator gives you your vertical asymptotes. Last number gives you your y-intercept. First number gives you your horizontal. Alright, so that part I'm not going to go over because you guys know it. I checked it. This is the new part. I want to make sure we do some examples finding the whole. So the last one here has a little tricky to it. And you're going to see some of these on homework. We're still going to factor the numerator into 2 parentheses. And we're still going to factor the denominator into 2 parentheses. The denominator should be one that you can get quickly. So look at the denominator. It's basically the same as it was last time. X squared plus 2x minus 3. Minus 3. Has to be a 1 and a 3. Just this time, which is which? Since I have a positive 2 here, I need the bigger one to be positive. That one's negative. Okay. Anybody remember what the numerator is called? It's a different type of factoring. So hint. So that's what it's called. A difference of squares. You have to remember how differences of squares factor. If you don't remember, that's okay. I mean, you can technically set up an x with it. Negative 1 would go on the bottom. It doesn't have an x in the middle. So that means 0 would have to go on the top. So anytime it's missing an x term, you fill it in with a 0. In order for it to give you 0 when you add, these have to be exactly the same. That's why it's called difference of squares. It's the square root of the bottom number. So it's going to be a 1 and a 1. This one's positive and one's negative. Differences of squares always factors into positive, negative, and then you just take the square root. Square root of x squared is x and x. Square root of 1 is 1 and 1. So that's, alright, so the common factor between the two is the minus 1s. So the minus 1s is the common part. So that means my whole is that positive 1. Again, you're setting it equal to 0 and solving for x, add 1, add 1. But that's only the x coordinate. To get the y, you take that number and you plug it into whatever is left. So I have x plus 1 in the numerator and x plus 3 in the denominator. And I plug in a 1 for each of those. 1 here, 1 here. 1 plus 1 is 2. 1 plus 3 is 4. And when I divide 2 divided by 4, I get 1/2. Reduce it. Don't leave it as 2 divided by 4. Make sure you reduce it to 1/2. Again, everything else is the same. Vertical, you would look at the denominator. So I'll go ahead and write it one last time, and I'll just leave it here. So denominator equal to 0 would be negative 3. Make sure you type in the x equals. X-intercept. X-intercept is the numerator equal to 0. So the numerator, the thing that's less than the numerator, is just the x plus 1. So x plus 1 equal to 0 is negative 1, 0. Oh, I wish I would have wrote these on top of each other. So here we have x plus 1 in the numerator and x plus 3 in the denominator. The y-intercept is the constant. So your constants are 1 divided by 3, which is 1/3. And your x's are 1 divided by 1. Your coefficients, which is just 1. This should be equal. That's the part we kind of skipped. But they're all going to be equal, so you don't have to worry about that. You just look at the numbers in the front. All right.